Assalamu alaikum. I am Dr. Saeed Ali Madan Azmi. Welcome to my channel. In this lecture, we will discuss exercise 15.2, question number 26 from Thomas Calculus 12th edition book. The statement of problem is integrate f over the given region, where region is a triangular region and function is f of x y is equal to x squared plus y squared. Here, the triangle is formed with help of these three vertices 0, 0, 1, 0, and 0, 1. So in the next step, we will plot the triangle. In order to plot triangle, first of all, we will mark x-axis and y-axis. I have marked x-axis with green color and y-axis with blue color. Then the intersection point is 0, 0. And along unit distance, I have taken the point 1, 0. Similarly, along y-axis, in the unit distance, I have taken the point 0, 1. Then I have joined 1, 0 and 0, 1 with the help of this red line. Then this is our required triangle in xy plane. Now, you know that the equation for x-axis is y equal to 0. Equation for y-axis is x equal to 0. But what will be the equation of this red line, which is joining the point 0 and then 1, 0? For this purpose, we will use this equation of straight line in generic form y is equal to mx plus c, which is called slope-intercept form. Here, m is the slope of the line and c is the y-intercept. Y-intercept means c is the point where this red line crosses the y-axis. So from the diagram, you see that this red line will cross the y-axis at point 1, 0, or it meets the y-axis at point 0, 1. So the value of y-intercept is 1. To calculate slope, we have the formula m is equal to y2 minus y1 over x2 minus x1. Now, we can take 1, 0 as x2, y2 and 0, 1 as x1, y1. And we can calculate the slope with the help of this formula. y2 minus 1, 1 is 0 minus 1 over x2 minus x1 is 1 minus 0. The value of slope is minus 1. So substituting the values of slope and y-intercept in this equation, we get y is equal to minus x plus 1. So the equation of this red line is minus x plus 1. In the next step, we will develop an integral for x squared plus y squared over this triangular region. We know that in order to integrate the given function f of x y is equal to x plus y squared, we can write it in generic form as double integral over the region R dA, where dA stands for this small area of this region. And then we have to check which variable is suitable for inner variable and which variable is suitable for outer variable. For inner variable, I have selected y as our inner variable, and in order to calculate the limits of y, I have passed a vertical arrow through this region. This arrow enters our region at the boundary y equal to 0 and exit our region at the boundary where the value of y is minus x plus 1. So the inner limits are 0 to minus x plus 1. For outer limit, we always check the range along the particular axis for which we have our outer variable. In this case, the range of our region along x-axis, because x is our outer region, is 0 to 1. So limits of x are 0 to 1. Now, after developing this integral, we can evaluate it. In double integrals, we always solve inner integral first. So I have isolated the inner integral with the help of brackets and change its color so that you are focused on this particular portion. In the next step, we will integrate it with respect to y. With respect to y, x squared is constant. So the integration of x squared will be x squared y, and integration of y squared is y cube over 3. After this, we will apply fundamental theorem of calculus, upper limit minus lower limit, to calculate the limiting value, like this, upper limit minus lower limit. For upper limit, we have replaced y with minus x plus 1, y with minus x plus 1. And for lower limit, we have replaced y with 0 and y with 0. upper limit minus lower limit. This is called fundamental theorem of calculus. So the second bracket where we have applied the lower limit becomes 0, and we are left with first bracket. So in the next step, we have to evaluate this integral. This integral is simple. Simplifying the function, we have opened up the bracket. In the next step, we have applied the integral on each term. The integration of first term is straightforward. We can calculate it with the help of power formula. We can take minus x outside, and we have x cube inside the integral. Next, in the second term, we have x squared inside it. And in the third term, in order to integrate it, we need the derivative of term inside the power as a multiplier. So we have multiplied with -1 and divided with -1 in order to create derivative of term inside the bracket. In the next step, we integrate it. After integration, we have some simplifications. After the simplification, we will apply fundamental theorem of calculus on each term, and we will replace x with 1 for upper limit and 0. And for lower limit, we will replace x with 0. So upper limit minus lower limit in the first term. For the second term, upper limit minus lower limit. And for the third term, upper limit minus lower limit. Now, making the simplification, we will get 1/6. Thank you for watching this video. Allah Hafiz.